Very soon you will be having a full period quiz on everything we've done so far in Chapter 7, not including the proofs. Today, tonight, and for homework, you will be doing the extra practice in your packet, and we'll do a few in each section just to get you started. Again, when you do sometimes, always, and never, it's a good idea to think about situations that will make these statements not true. If you can't find a way to make a statement not true, it's probably going to be an always. Okay, so let's start with the first one. Two squares are always, sometimes, or never similar. Well, for polygons to be similar, they need to have two things true. Sides must be proportional and angles must be congruent. If you think of two squares, any kind of squares, is it true that the angles are all congruent? Yes. And what about the sides? Would the sides always be proportional? If this is length 2, 2, 2, 2, and this is length 3, 3, 3, 3, they would have a proportionality or a scale factor of 2 to 3, and so they would be in fact similar. So the answer to this one is always. Let's skip down to letter C. A right triangle with a 20-degree angle is sometimes, always, never similar to an isosceles triangle with a 20-degree angle. Okay, let's see. So a right triangle, we know if it has a 20-degree angle, it must be 90, 70, and 20. So this is a little small. So you'd have a 20 and a 70. 20 degrees in here and a 70 degrees in here. So a right triangle would be what? 90 degrees, 20 degrees, and 70 degrees. And a isosceles triangle with a 20-degree angle could either be a 20-20, maybe the base angles are congruent, so that would mean the vertex angle has to be 140. So that's one setup for an isosceles triangle. The other one could be that the vertex angle is 20, which would mean what's left over from 180? 60. I'm sorry, 160. So that would mean each base angle would be 80 degrees. So if you look at this configuration, there is no way that these two triangles would have congruent angles. So the answer to letter C would be never. Okay, going down to 2B, you're giving that A, B, C, and you want to figure out if their triangles are similar. Oh, I guess they have to be similar. Use the correct order, give the reason, and the scale factor. Okay, so we have this thing going on, which means that this angle must be congruent to, angle E by vertical angles. Likewise, angle B and angle D are congruent because of not vertical, alternate interior. And of course, you know that angle C and angle C have to match up. So we know that angle A matches up with angle E, angle B matches up with angle D, and angle C matches up with angle C. And the reason is angle-angle similarity. So now we have to make sure we check out BC to DC. BC is 4 and DC is 10. So 4 to 10 can be simplified as 2 to 5. So the scale factor is 2 to 5. Okay. Let's set up this one on number 3. You have triangle ABC similar to DEF. Find X and find Y. So if they're similar, that means your sides are proportional, which would mean that AC is to FD as, let's find some numbers. AB and DE, 5 to 6. So you would solve that. Let's set up Y. Y is over here, and Y is FE, which matches up with BC. So 7.5 is to y as 6 is to 5. 5 is to 6. And you would cross multiply and solve that. I'll give you a hint. The answer to x is 10 and y is 9. So you can check that, but please make sure you can do that yourself. Going on to the next page. In the diagram below, they tell you that quadrilateral ABCD is similar to EFGH, and it's actually matched up correctly in the diagram. Find the exact values of W, X, Y, and Z. So maybe we can't do it in order, but let's see what we could do. Well, angle C, we can fill in things that we sort of know. Angle C lines up with angle G, so this has to be 122. Oh, so we can figure out this all has to be 360 because it's a quadrilateral. So that if you do the math out for this one, 86 plus 122 plus 91, subtract that from 360, you'll get 61 degrees. So that would tell us that angle W is 61 degrees. And then you could probably set up some sides are proportional. Let's just set up one. Let's set up angle side X. AD is to EH, so X is to 8, as, now we have to find two sides that have numbers to solve for X, as 9 is to 6. Maybe we'll set up another one. How about 10 is to Y? 10 is to Y as 9 is to 6. And then for Z, 18 is to Z as 9 is to 6. So solve those all out. Here's a ratio question. The ratio of apples to oranges are 7 to 9, and there's a total of 848. How many are apples? Apples to oranges. So we know the ratio is 7 to 9, which is the same as 7x to 9x. And we know that the sum of those has to be 848. So that's a hint to get you started on that one. The angles of an octagon, you have to know what the angles of an octagon are, what they sum to, which is the trickiest part of this because really this is the ratio, so we really just want to add these all up. If 1x plus 2x plus 3x plus 4x, etc. has to equal the sum of the angles of an octagon. We'll go over that in class, or I'm going to actually be giving you some answers to some of these. So the next one is going to be, this might be a quadratic. Let's see what this looks like. So you're going to have x minus 2 times x plus 3 equals x squared. And we have to FOIL this correctly. X squared minus 2x plus 3x minus 6 equals x squared. We're combining like terms. So I guess if I subtract x squared from both sides, the x squareds will cancel. So I'd be left with 0 equals x minus 6. Adding 6 to both sides, I get x equals 6. This one, I think it's going to be an actual quadratic where you're going to have to factor it at the end. Save that one for you to do. Let's set up this one. Find the value of x in each diagram. Well, these two triangles must be similar because of angle-angle similarity. So we know the scale factor is 4 is to 10, which is the same as 2 to 5. So we know that 4, which is the little triangle, is to 10, as the little triangle, 2x minus 5, is to 20. And you can solve that out. This one we have to be a little bit careful because we know that this angle matches up with this angle. This angle matches up with this angle. So we sort of have to be careful. So these two are similar by angle-angle similarity. And we have to figure out where x would match up with x plus 16 because this angle and this angle are congruent. And x lives between this angle and this angle. And x plus 16 lives between the congruent angles. 3 matches up with this angle, and 12 in between this angle and this, and 12 matches up with this to this. 3 is to 12, or you could put 1 to 4 if you want to. And you want to solve that by algebra. And then this last one we'll save for class, next class. So finish this worksheet for tomorrow's class.